All welcome to another session with me, Varun, on Tech Tablet. In this video, we would be talking about a linear regression code that focuses especially on the procedural aspect of how to work with the algorithm, which is linear regression. I am pretty sure most of you must already have gone through a lot of this, that is how to work on linear regression, what linear regression is, what are the basic steps. However, we would be focusing a bit more on the real-time aspect of it, probably wherein we would see what are the elements that need to be cleaned, how do we work on the betterment of a model, how do we compare one or two models. And yes, this would be a series of videos that would be covering the real-time issues faced by a lot of data scientists or by a lot of data analysts who are working on real-time. I've also noticed that most of the videos on YouTube, they do cover a generic tutorial on how to work on a linear regression code. However, do not provide a deeper insight because this was one of the biggest obstacle faced by me as well as a developer when I was working with data science and when I turned up to YouTube or on Google. Most of the content was pretty limited to creating a model and finding out the error or accuracy and nothing beyond, which would hardly help in real time. So in this video, let us try to go as real as possible. Again, the goal is not to overwhelm each and every user with a lot of information, but the goal is to go step by step. So we would be creating at least 3 to 4 videos on linear regression, which would be covering most of the real world aspects. We would be going into logistic regression, thereby we would be going into decision trees. So yes, this is a series of videos. So I hope you really enjoy it and you gain something out of it. So now, without wasting any time, let us quickly go into understanding what is it that we would be covering as a part of this uh, video. So the first thing that we would be talking on, or that we would be trying to understand in this is how to create a data set. So we have how to create a data set, which would be the first thing. After we see how to create a data set, then the next thing would be to understand the data set better. So we would be taking a quick check at what all we want to see in the data set. So a quick check on the data set. Again, this would be covering null value check, multi-collinearity. We would be checking for, I mean, if there is a need for standardization, we would be doing residual check. Uh, and yeah, I think we would also be seeing the description. We would be seeing if there is correlation, etc. So yeah, we would be just, looking into a quick check on the data set. Then, once we know that the data set is good, we would be seeing if, okay, we would be creating a model next. I mean, a model on machine learning. Once we create a model on machine learning, we will see the output. I mean, the output would be seen and we would create a new model. Okay. Now this new model, in this new model, we would, I mean, the goal is to see if we can better the model. Okay. And finally, we would create a new model again. Okay, I think we have this. So the output would be seen and we would be creating a new model based on the output in step 4. So firstly, let's, go to this and we'll see how, different aspects impact each and every column. So to that, let us firstly, quickly move into the data set. So here, as you can see, I've been working on the code just a while back, and let us do the steps first. Let us do the needful. So in the first step, we are seeing how to create data set. And to that, we have a couple of libraries that we have imported. Again, there would be different libraries that we would be taking in as per the need. but the first of them is NumPy and Pandas, which happen to be the most important ones. Then we have sklearn, which is a machine learning library, wherein here we would be pre-processing the data and using one hot encoder. And here we would be checking the matrix in which we have MSE or R squared, etc. I'm just using random seed so that the values generated here come out to be at random. However, you can try changing different numbers. I'm sure that would do the set for you. So here I'm generating a sample size of my data. So I'm instructing the IDE to generate a data set with size of 1,000. After which I am pre-deciding on certain values of data set, like I want the age, I want the car age, age of the person, car age, the age of the vehicle, the annual mileage that it gives, and probably the number of accidents. All of these values are being taken completely at random. So here the normal age of a human goes from 18 to 70, not taking it below 18 because the license in different countries does not permit you to drive below 18. The age of the car can be 0 to 15. Again, I'm taking it as 15 because usually the governments do not allow you to drive a vehicle after 15 years. In different countries, it varies. Considering the annual mileage to be, from 15,000 to 3,000. Okay. And then considering the number of accidents, again, yeah, using Poisson distribution here. Then we are considering some random, features for gender and car type. So I'm taking four, models here, which is a sedan, SUV, a truck, and a hatchback. And yeah, in genders, I have male and female. So all of these would be moving in, would be adhering to the size of 1,000 because that is the values, number of values that we're looking at. And then finally, I have another column which is base premium, into which I've taken a small mathematical value here, all right, just to keep the data a bit complex, and finally pushing them all into a data frame, right? For that, I've been using pandas, considering data frame, renaming each of these as needed, and pushing the values into each of these. So here, as you can see, the first step that we need to do is to be able to convert the gender and car type into true and false values. So here, if you can see, the gender is male and female, and car type is these four values. So to that, what we are doing is we are converting each of them. So we have a male here, and we have all the three models. You are not seeing a female and you're not seeing a hashback because we've dropped the first value. So if it is true, then it is understood it's a male, and if it is false, then it is understood it's a female. So it's implied, right? Now that the first part is done, now we're moving to the second part wherein we are trying to understand the different data types that we have. If you remember, now we would be going on further to understand the data set. We'll see if we have any number of values, if we have multicollinearity, if we need to add or remove any values as per the need. So here I am using encoded, considering data types, right? After which I am, checking my correlation. Okay, so here you can see I have a mix of int values, float values, and Boolean values. Then I'm moving into checking my correlation. We all know what correlation is. I'm hoping correlation generally tries to identify the relationship between two specific variables. And here we are trying to see, or we are trying to understand the relation of every other column with the column premium, right? Which would mostly be our target value as per the data. So here I am considering premium using correlation, and then I'm sorting values, which is false. So you can see how the values are arranged in descending order. When it says ascending is false, then it's descending, it's implied. Now here there are only two values that we need to actually take into consideration. The rest all seem pretty fine. The two values that I'm referring to are the number of accidents, which is 0.83, and the age of the person, which is minus 0.2. So it directly means that this has a very strong positive correlation, which means that more the accidents you will have, you will end up paying, a higher premium. And here also, when you talk about the age, we see that it has a moderate to a weak correlation, but yes, it is definitely a bit stronger compared to all other values, right? So here I have, we can see the relation between age and premium. That is, the more you age, the lesser your premium goes, right? So we have one strong relation and one negative, or one positive relation and one negative relation, which is understood. Now, what we'll be doing is we'll try to see, how are these values performing when I put it up against scatter plot. And ideally, there should not be a trend. And if you're, noticing a trend, then I think there is a problem with the data set. And here, if you can see, there is no, specific trend or pattern. We see how it is all scattered, which gives us a good feel. Here we can see how premium and car age are related to each other. Okay, we see that there is a direct linear relationship. Here also we see how annual mileage and premium are not very strongly related, but still we see that there is a trend that is moving upwards. Like if you notice it, you would be seeing this kind of a pattern. Like if you just fit it to this, you pause the video and you fit it, you will be noticing a pattern, a very slight pattern. And then we can see how premium and the number of accidents are also directly related. That is, greater number of accidents, more the premium you'll end up paying. So we have understood that there is a direct linear relationship between a few values when you're connecting it with the premium of the data set, which happens to be uh, your target variable, right? Now, having said this, what we'll do is, I am pushing X, with the values wherein I am dropping premium and I have rest all other values into this. So basically, this will have all my independent uh, features, right? So here you can see there are a plethora of features that I have taken, after which I would now try to check the multicollinearity of these values, right? Now we all know that my values are passed within X. Now X is the one which has all my columns or all my features loaded into it. So now to that, I would be checking my multicollinearity. So what we are trying to do here is we are trying to do a check of all the variables first. We're trying to check the data set first. We're trying to see if it satisfies the assumption first. Because if the columns do not have a linear relationship at all, or probably if they have a non-linear relationship, then probably this algorithm in itself would not be the right choice for you. So you might have to vary that. So it depends on a lot of things as to if this is the right algorithm that you want to work on, or if there is something else that you're looking at. So it so it becomes very inevitable for us to do the checks, right? So now we are doing a multicollinearity check, and to that I'm using variance inflation factor, VIF, which is a part of my stats model. If you haven't ever heard about this, then I would very strongly recommend you to go into the library and check what it does. It basically gives you the values of multicollinearity, and when you see this, it is up to you to understand that values which fall within a range of 5 are safe, and if it is going above 5, then you might have to act on it. So here I see that almost all my values are pretty safe except for number of accidents, right? So number of accidents here you see has a value of 5, which is not very happy to see. We see that this column is actually, having a good, relation, or, it's having a, it is affecting the model, right? Then you would be checking the null values. I don't see any null values. Again, we did not induce any null values when we were creating the data set. If you can check here, I have not added any null values, or neither have I added any outliers nor missing values. We try to keep it as realistic and simple as possible. However, in the next video, we would be covering or we would be working on a more complex data set, which would be probably taken from an external source. You would be reading the data set and not creating a data set, and we would be trying to handle different kinds of problems like null values, outliers, scaling, standardization, etc. Now, going further, what we're doing is I see that there are no null values. Now, to the final test, I would want to evaluate the residuals. I hope you all know what is a residual. Residual is the actual minus predicted values, which generates the error, right? And why is it important to work or to check the residuals is because they help you. I mean, if there is a trend that you notice in residual, then probably you might have to rethink on the data set. And if there is no pattern noticed and if they are dispersed at random, then I think you are good to go. So here what I'm doing is I am splitting my data set into train and test. I'm dropping the premium from my independent variables, pushing it into y, having all other variables in x. Now, passing this into train test split, applying the linear regression model, fitting it to my train values first, predicting it on my test values. So from here to here, you would notice that there's no huge difference. It's all exactly as per the standard flow. However, here is where we would be trying to plot the residuals. So what I'm doing is in my X, I'm considering the predicted values, which is Y pred, and in my Y, I'm considering the residual values. And you can see that my residuals are not having any significant pattern, which means that there is nothing for me to get scared of, which means that I can very confidently move into my next step. So now I'm considering the cleaned values, passing them into premium, and again splitting the values for test and train, pushing them into linear regression, fitting the values. You can also probably just check if the values are fitted or not. And once they are fitted, you can predict the values using ypred. Now, again, I do not wish to see the values, in a data frame. However, if you are interested in that, you could create a small data frame, or you could create a small table, just generate the values of ypred and xtrain or xtest, and I think you should be having your values. So xtest would have the actual values. This would have the predicted values. So now what I'm doing is I am considering the MSE and R squared values. And when I want to, finally see them, I would be, printing them in a format which would be a bit understandable to human eye. So to that, I'm, generating my model coefficient, an intercept, an MSE, and an R squared value. Now that I have MSE, I don't need again, I don't need RMSE again. I mean, yeah. So what I'm doing is I'm considering my model coefficient. So here you can see the values from here to here. Uh, then you have your intercept, which is this. Now we'll understand each of these. Okay. Then you have your mean squared error, okay, which is 2399, and then you have your R scored. Okay. Now, just to have a very basic level understanding of each of these, the first one is R squared, which is 0.89, which is a terrific score. Again, I wouldn't say it is an amazing score, but it's a good score. It explains that your data set is able to explain 89.4344% of the variation in insurance premium, which means it is a very direct statement that it is a strong fit or a good fit. Okay. Then you have your mean squared error, which stands at 2399. When you square it, the value goes to somewhere at around close to 50. Now, by this, it means that your average, I mean, your model is predicting maximum within a range of 49 units from the actual premium. So it gives you that. And then you have your model coefficients here, as you can see. Basically, what this means is if you have more accidents, then you're paying higher premium. If you have less accidents, then you're paying. It basically talks about the relation, like the effect of each and every column on the data set. And then I think we have okay, I think that's what we have. And then multicollinearity is something that we already spoke about, needs no special emphasis again. So what does this say? It says that your model has a really good explanatory power. It has significantly low error, and it can produce interpretable, meaningful coefficients, right? Which means that your prediction would be stronger than usual, right? You have a good model that's been created. However, the goal is to probably better the model, and to that, what I'll be doing is I'll be again. These are the steps that I'm doing on the go. That I've done on the flow, just for you to understand. So what I'm doing here is I would want to probably make some more changes to it and see if I can better the model, right? And to that, I would have to play around with a few features so I can fine tune them. So the first thing that I would be doing is adding log transformation to the mileage and adding square root to the number of accidents. So the values, conquer a bit, and we assuming that the values may be skewed. Then I am trying to add or introduce polynomial features wherein you can see I'm squaring the age and the car age. All right. Then I'm eliminating the actual values of these, and obviously, because now that we have transformed the values, we would want to ensure that these values are the ones that are going in. So here, if you can see, I'm not using, I would be, all right. So here in features to use, we have added the original ones as well, and we would be later removing the ones that are unnecessary. So I have X values here in features to use and premium in my Y. I would be scaling them. And after I scale the values, I would be predicting them again using ridge coefficient. Now, when I use my ridge values, I can see that I have an R squared of 0.81 against 0.89. However, if I change the value from 1 to 2, you would be seeing very minimal change here or here, which means that the regularization effect is probably not very significant on all the values, which indirectly gives you an understanding that probably your linear regression was doing a good job. I mean, the way you fit your first linear model was probably the best way to do it. Now, what I'll be doing is I am considering my linear model. I'm considering my, okay, linear model and a ridge model as well. And I'm creating a small pipeline into which I'm pushing the X and Y values. So I have a pipeline that is being made for linear regression and one for ridge regression. I hope you all know what's a pipeline. A pipeline generally covers multiple aspects or multiple blocks of code into one, so you can easily stitch them together and generate it out as one single output of or generate it as one single piece of code. So here you can see I'm using standardization and linear regression, pushing them both into one single pipeline, stitching them together, and when I want to apply a step, I would directly be using my linear regression pipeline, right? So that's how it goes. So now what I'm doing is after I create a pipeline, I'm making a k-fold validation or a n-fold validation within which I would be taking 5 splits, and in these 5 splits, I would be passing values. I mean, I would be having 5 different sets of values to see if how my model is performing. Created a pipeline of linear regression and ridge regression, and I see that my model here also does not change much. So even in my linear or ridge, I see that this model is not outperforming another, even if I have changed my values from alpha 1 or alpha. So here, if I change this to alpha 2 and I generate an output, I still do not see a very huge or a significant change, which means that there is no significant multicollinearity or overfitting. Regularization may not be needed by much. The chosen alpha value may be small. However, we've tried changing the values and it's not creating a lot of impact. And finally, the model capacity may be maxed out. So these are a few, values or interpretations that we have, which we would have, which even you would be understanding when you try to create a model. So my recommendation to you, if you're trying to work on a very similar model, please create a data set which is probably aligning with this. However, try to, bring out a few changes in it. Try to change the values mathematically. Try to add a couple of more values. Try inserting null values, try inserting outliers, and see if the behavior of the algorithm would change. In the next video, we would be talking more on how to work on the actual cleaning part of the data set, how to work on a machine learning model, and probably how to work on polynomial regression now that we've had a basic understanding of linear regression. If you have any queries that you might want to ask or that you might want to get solved on, do not hesitate to reach out in the comment section. And also, do not forget to check out my other channel, which is Hyderabadi Chora, in which you will be seeing another creative side of the same person talking here on a technical parlance. Thank you all. I hope you all have a good day. And if you're preparing for your interviews, then I would recommend you to go through the video again to listen to the keywords and probably perform well. And best luck towards that. You all have a great day and a good year ahead. Thank you.